today's webinar is about Pix4Dmapper workflow and options. And if you are watching a replay of this video, then you can always send email to our support, which is support@pix4d.com, or watch our very extensive knowledge base directly on support.pix4d.com. All right, so let's get started. Today's agenda is going to talk at the beginning a bit about the basic workflow and a bit some more advanced workflows too, in which you can use Pix4Dmapper. I underline a little bit the rapid processing mode, which allows you to have on-site quick quality check. And then I'm going to go in more details about the Pix4D wizard that allows you to generate, when you generate a project, when you create a project, which are the options which are available to you. Then we will go slowly through each of the options which are about the step 1, the step 2, and the step 3 of the processing, with a few examples there. Then we will talk directly about what are the options which are the most relevant if you need to increase the processing speed, if you want to make the processing faster. Then we also talk about some of the options which are available when the thing which is most important is the accuracy of the project, or when you have some projects who are not working very well. Finally, we'll conclude this presentation with an advanced topic, which is about managing very large projects. And most important from that, the way that Pix4Dmapper is able to handle that is usually by splitting and merging existing projects. And we're going to discuss about the details on how to make this happen. All right, so Pix4Dmapper workflow can be used in multiple fashion, but the easiest way of using Pix4Dmapper is, if you're in the case where you don't have any ground control points, is basically you generate a flight plan using a flight planning software that usually comes together with the UAV that you have. Then you fly and you acquire the images. You take the images, you put them inside of Pix4Dmapper and click on Start, and you get directly the results, the DSM, the automosaic, and the point clouds. Now, if you have ground control points, and to understand better the cases where you need the ground control points or not, I would refer you to this other webinar, which is specifically about ground control points. Then the steps are slightly different. You first start with a flight plan. On the ground, you go and mark and measure ground control points. Then you fly and you acquire the images using your UAV. And then you have two methods which are available to you. The first one is to process step 1 of Pix4Dmapper. The second one is to use the ray cloud to mark the GCP, and then to re-optimize step 2 and 3. The other method, if you don't want to, or you can't for some reason, you pre-process the project with step 1, is we have also an interface which is called the GCP editor that allows you to mark the images directly there, and then run the full chain of processing without any intervention. The benefit of method 1 is that the ray cloud makes it much easier, much more efficient to do the GCP marking. However, it requires that you spend a little bit time of doing the processing step 1 in advance. And I would like also to introduce and to one workflow which is very, very useful in practice, is one of the features which is inside of Pix4Dmapper is the rapid check. The rapid check is basically a way of processing the data which is much, much, much faster, but trading off this speed for some accuracy. And a really nice workflow to use in practice is to do a generate a flight plan, to fly and to acquire the images. And as soon as you landed your UAV, you take the images and you put them in your laptop and you run a Pix4Dmapper rapid check. I will show a bit more examples of what this rapid check means, but this will let you know if you have acquired sufficient data with respect to your specific data set, or if possibly you would need to take more data. And you can do that right on the field, thanks to the really quick, the very fast speed of the rapid check feature. This will, after checking the report of this rapid check, you will be able to tell if potentially you will need to fly again to acquire more data, or if you are all fine and you can move on doing the full processing either on your laptop in the field or back in the office. Something very important to know, and which is also underlined in the webinar about optimal flight plan, is the fact that to have a very good and a very accurate project, it's incredibly dependent on the quality of the flight plan and the images you acquire. And when you start to have very low overlap, or that the terrain is very complex and which would require even more images, if you try to process nevertheless the project, it is possible, but it's much more complicated and potentially very difficult to assess correctly the accuracy of a project with low number of images. The rapid check really allows you right on the spot to understand if potentially you will need more images for your project. So in reality, what the rapid check is doing is that it's reducing the resolution of the image before the processing. And it may happen that some rapid check processing may fail, and even though that the full processing may succeed. However, it never happened the opposite. If you have a rapid check working perfectly, then you can be 100% sure that the full processing will work too. So you may use the rapid check as an indication to understand if it's going to fail for sure, or if the chances of it working nicely are very high. The best example is to look after you've done the rapid check, you will get a quality report. And to give an example, in this example, we did the full processing on the left and the rapid processing on the right. One of the things you can really observe is that the number of key points has decreased a lot in the between the two reports. This comes from the fact that we are using smaller images, and smaller images means that we can detect less key points per image. You can also see that the full processing indeed has calibrated more images than the rapid one. This is very normal and to be expected. However, when you can see also that not every single images have been calibrated in the rapid, this is basically a warning that can make you understand that this data set is probably not an easy one, it's probably a challenging one. And even though it processed nicely in full, it would potentially be even more accurate if you had a bit more data, a bit more images, a bit more overlap between the images. A nice way to see it is also using another graph from the quality report, where again on the left you've got the full and on the right the rapid. You can see basically that on the full images, on the full processing, there is nice relation between most of the images. However, in this part, the relation between the images is quite poor. It's not as strong as in the other part, which may lead to some potential inaccuracy in this area. If you look in the rapid mode, already by doing the rapid, it already gives you a hint that actually this may be the case, as the rapid managed to nicely calibrate the places where in the full it was really well done, and it didn't work in the places where in the full anyway it was not very well matched. Maybe just as a rectification, when the rapid mode, you don't have to change your images and anything. The software is doing everything for you. So you have the same project, and just at the beginning you have to select between rapid and full processing. Maybe as an example, I can show in this. This is Pix4Dmapper, and on the bottom you have the local processing dialog. This is where you can choose between full processing and rapid check. And the software is going to automatically handle the images in a different way. So to conclude on the rapid mode, we really recommend this workflow, especially at the beginning when you maybe don't have the most experience on what are easy data sets, what complicated data sets, as you can really have on the field a proof that will let you know if back in the office your data set will work for sure, or maybe could benefit from additional imagery. Okay, let's now move on to the options which are available when you create a new project in Pix4Dmapper. So maybe I can just show how to create a new project. Or maybe not. So here on the right, you've got an image of the wizard that you can follow when you create a new project. You're greeted with 3 choices, which are aerial nadir, alternative processing mode, and aerial oblique. They are not very different than each other, but they have a few specific things for each of them. The most general one, and the one that probably you're going to use the most of the time, is aerial nadir. This is the most optimal and the most efficient when you have a UAV project which is flown in a grid pattern with the images pointing a bit. Doesn't need to be exactly to the ground. It can be more or less pointing to the ground. The goal usually of this project is usually to generate DSM and auto mosaic. In that case, this aerial nadir is the best option that you can choose. However, as an option to this aerial nadir, there is something called alternative processing mode. This alternative processing mode is there especially made for when you have some very challenging data sets. As explained in other webinars, some of the very challenging data sets are like farms, when you have fields, sand, trees. So either surfaces with extremely complex pattern, like vegetation, or crop, or fields, or projects which have very low pattern, very uniform images, like sand or snow, this type of data sets. They are usually challenging, and sometimes it may happen that when using the normal pipeline aerial nadir, you will have a huge number of, you can have quite a number of images which are not calibrating. For these images, we recommend to use this alternative mode. And it's much more robust, meaning that the likelihood of having most of the images calibrated will be very high. However, sometimes the results may be slightly less accurate than with the full aerial nadir pipeline. So in general, we still recommend to use aerial nadir, but for some specific data sets where you have much less images calibrating, we offer you the opportunity to choose alternative processing mode, which will probably have you many more images calibrating, and maybe it may happen that you have slightly less accuracy. Then we have the aerial oblique and terrestrial. The main difference with respect to the first one in this mode is that the software will basically know that it doesn't make any sense to try to generate a DSM on an automosaic from images which are extremely nadir. And it has also a few specific tuning for imagery which is taken from the ground. So basically, if you do a project which is heavily from the ground or with a copter around a house, potentially the aerial oblique is the best mode for you. Then you have the name, which is any name which will be in your project, and all your names, all your files that are generated will have this name inside of the files, and the directory where you need to create them. And then just at the bottom, there are two options. The first one is the one by default is to generate a new project, and the other one is allowing you basically to merge several projects that you have been creating before together in one single project. But I'm going to talk more about this mode at the end of the presentation. After selecting OK, you will be greeted with this next window, which allows you to select the image properties. The first option there is about the image geotags, the coordinate system of the image geotags. And by clicking on edit, you can select a different type of coordinate system. However, if your UAV or your geotags are taken in by a standard GPS, very likely they will be in this VSG84 coordinate system. In that case, by default, and if you don't have any GCP, by default the results will be in UTM coordinate system. However, if you select another coordinate system for your geotags, then all the results will be also in that specific coordinate system, except if you have GCP. So just to summarize, by order of preference, the software will put the results in the coordinate system of the ground control points. If you don't have ground control points, then it's going to choose the coordinate system of the geotags. And if your geotags is in GPS, then the results will be given in UTM. You can also, from this three button, you can use them to geotag the images by either selecting from an external file, and we support several formats which are now well described on our support website, or if the geotags were written inside of the images, the software is able to detect it automatically and to read it. The software Pix4Dmapper is also going to read the camera information based on the EXIF of your images. For most commercial cameras, point-and-shoot camera, this information is well defined and is usually the camera name with the brand of the camera. By pressing on Edit, you will be given the whole list of cameras, of choices of camera that you can choose for this project. If the camera is not in our database, that's all right. You can process your project even without that. What will happen is that the software will start with the best guess parameters, which you can also help to refine manually. Then the workflow is to take a good project meaning basically a project with enough sufficient overlap, and process it. The software in the quality report will give you this table. This table will give you the initial values, so that's the values of the camera which you have set either manually or that were extracted automatically from the EXIF information, and you will get the optimized values. which is the values that the software has computed from your imagery. If the result looks good, then you can be quite confident that replacing the values in the database, which are just there, with these new values is going to give you a more robust and potentially more accurate calibration in the future. Okay, so now let's go into more details about all the options in Pix4Dmapper. So in the local processing dialog, you have an option button. If you open this option, you will be greeted with this window, which has a tab, a specific tab for step 1, step 2, and step 3 of the processing. In addition, you will also have a tab which is called resource, which allows you to spend less CPU resources to the processing if you want to do multiple activity at the same time on the computer. But for best processing speed, we recommend to always put the maximum resources to your processing. So you have again the choice here to change between the different processing modes, which I already explained just before. In addition, you also have the choice to choose this feature extraction size. This option is generally is the best to leave it at 1 and never to change it. When rapid processing mode is happening, actually here the feature extraction is done on a much smaller scale. But by default, there's very little time where we need to change this option. It may happen if you have extremely small images as inputs, maybe 600 times 400 type of resolution, 1 megapixel resolution. Maybe for this type of imagery, you can select the feature scale of 2. This sometimes helps for extremely small images. On the other hand, if you have an extremely large data set and your images are extremely large, maybe 50 megapixel or 100 megapixel, then you can increase a lot the processing speed by reducing the feature extraction to, instead of 1, selecting 1/2 of 1/4. And you will, with such large images, there will almost be no difference in accuracy at the end of your project. Then there's the tab called optimization. And there you have two main options. One which is about which parameters to optimize, and the other about rematching images. So the optimized parameters is about the software is going to try to find for each camera what is the real position and orientation, as well as the focal length and all the parameters of the lens and so on. This is usually what we call external. External is the position of the camera and its orientation, and internal are the parameters such as focal length and lens distortion. By default, the software is going to try to optimize all the external, meaning the position, as well as the internal, meaning the focal length. However, in some cases, you would like to tell the software not to optimize all the camera distortion. This is especially true when you have cameras with slow rolling shutter speed, which makes some effects in the images which confuse the algorithm and may lead to failed processing. So for very specific type of cameras and images, which basically when you have a very slow rolling shutter speed camera, we would recommend to not optimize all internals, but only the leading internals. The other option you have there is called rematch images. For this, I have an example there. With rematch, the software is going to try to calibrate all the images in the first step. And in addition, is going, once it finds the real position for all the camera, is going to look back at each single images and try to find new matches between them. This usually increases the accuracy and the number of calibrated images for project. However, it may add quite a lot in processing time. And when you have a very, very large number of images, this usually starts to be not very useful anymore. So by default, this option is enabled for small data sets up to 500 images. And for larger projects, this option is not set by default on. However, in the software, there's a button called Rematch and Reoptimize in the main toolbar, which has the same effect as having this option Rematch Images. So in any case, you can always try to increase the number of matches in images, but by default, this is not on for projects larger than 500 images. Then you can select which outputs to produce during the initial step. The first one is producing many, many text files, which are also described in the knowledge base, which are mostly used when you need to interface Pix4Dmapper calibration results with other third-party software to know the position of the images and the type points. The second option is to undistort the lens effect for each images. Let's imagine you would have GoPro type of very fisheye GoPro images. If you click these images, this feature, then after the first initial processing, it will give you in a folder all the images without the round effect of the lens, but with really straight lines. Then the last option is to be able to generate directly from step one a low resolution automosaic. The resolution is computed to be 8 times the value of the ground sampling distance. So it's very likely going to produce you only a small automosaic, but very useful if you need very quickly to get already a view of the terrain. Just to give an example also, as I was mentioning this rolling shutter, most point-and-shoot camera have a physical shutter. In that case, you cannot have this. You don't have any problem with rolling shutter. Some cameras which are mostly designed for filming, like the GoPro, have also a rolling shutter. However, in the case of the GoPro, the rolling shutter is extremely fast, and it's not producing any artifact while taking the images. However, some other type of camera might suffer from an effect where this line in reality should be straight, but because the images was taken in line by line in a very slow fashion, because of the vibration of the copter it was on it, you will basically see that some lines are taken while the camera is watching in one direction, and some lines while the camera is watching in another direction, giving you basically this wobbly effect. If your images are like that, then we would really recommend to use the alternative processing mode, and to, in addition, in step 1, to select optimize leading internals only. If this still doesn't work, then you can choose the third option, which is optimize external only. Okay, these are most of the options for step 1. About step 2. The first box is about pixel matching. And this is what transforms your camera, which have been calibrated into in the first step, into a very, very dense point cloud in the second step. So there are a few options there. In the pixel matching, you have the first one, which is the image scale. This is in the algorithm for doing the pixel matching are working based on a certain size of image. From experience, most of the point-and-shoot camera and even a DSLR camera, Canon 5D and so on, have the best results when this 1/2 image size is selected. And with most of the camera, you will not have benefits of going into full image size when doing the processing. We would recommend to go to full process image scale only when you have a camera which is extremely sharp, maybe like a Hasselblad type of camera, but usually you don't have any benefits with most of point and shoots and DSLR camera. However, this scale has a huge effect on the number of points which will be generated, and in a certain respect also the accuracy at which these points are generated and the speed at which these points are generated. So as an example, in these two examples, the first example was done at scale 1/2, which is the default scale, and for this small data set, it generated 3 million points. By choosing scale 1/8, you would generate also many points in the same area, but much less. However, something very interesting to note is that to generate the model on the right is taking basically potentially 16 times less time to produce. And in terms of resources for the computer, you also need almost 10 times less RAM than the first project to be able to output these results. So the image scale has a huge impact both on speed, on resources needed, and on results. And for most of data set you will produce, you will have optimal results by 1/2. If the DSM is not your main interest, if the 3D shape of the terrain is not of your main interest, you may very well choose a smaller scale. There's also this option which is called multi-scale. This option is especially useful when you have vegetation. Multi-scale means basically that the software will try to match the pixels at different size. And for example, a tree, in most of the data sets, tree cannot be matched on a pixel level because they are too complex. They have a shape which is extreme. The pattern is way too complex. So for this type of data sets, it's much more beneficial to process them at a smaller scale. And this option multi-scale is basically processing your data sets at at the scale which was chosen here on the first in the first option, and then also at all the smaller scales, and then combines the results in a very smart way. And this allows you to have the most uniform type of sampling of points in the whole project. However, sometimes using multi-scale may add a little bit of noise on very sharp edges. So for example, if you have a house, by selecting multi-scale, you may have a little bit more noise artifacts on the edge of the roof than if you didn't choose multi-scale. However, by default, these artifacts are quite marginal and can be corrected with the point cloud filtering, which is just below. The other very important option is point cloud density. By default, the setting is set to optimal, which is, again, for most of typical camera, a good way of going from pixel to pixel. By choosing a lower, you will have potentially 4 times less. If you choose the point density low, you may have 4 times less points, but also the processing will be 4 times faster than if you didn't select this option. In addition, if you would, however, if you would select high density, you potentially may have 4 times more points, but also the processing will be 4 times slower. And given most of the images we are talking about in UAV and point-and-shoot cameras, this is an overkill. You will not have more 3D information and not more accuracy by adding these points. And optimal is again the best choice in most of the projects. After the point cloud have been generated, we also generate we're going to filter them to potentially improve the accuracy and improve also the visual look of them. There are by default two types of filters applied. The first one is the noise filtering, and the second one, the surface smoothing. So the noise filtering is basically going to make statistics on the points and try to detect when a point is too far away from the other. The slider that you have there is basically going to let you choose between extremely small objects to remove or potentially larger ones. So by default, the middle is perfect, but if too many points have been removed during this step, then we would suggest either to cancel the noise filtering or to put the slider more on the left. However, if the output results is still too noisy, then we would recommend to move the slider on the right. The second filter is about surface smoothing. And what basically is going to happen is that it's going to remove little details because most of the little details are mostly noise than actually real feature of the terrain. The settings here is going to allow you to basically choose how often you want this filter to be applied. By sharp, it's going to try to remove objects only once. By selecting smooth, it will do multiple iterations of this algorithm over your data sets. The radius is again a little bit the same as for the noise filtering. If you put it on the left, you will only remove extremely small details, and the more you push it on the right, potentially the bigger features will be also removed from your project. These two filters can be also unchecked for the processing. Then the output, by default, PLY will be generated, but you can also, in addition of the PLY, generate multiple other file formats. So as an example, this would be an effect of the noise filtering. So the more on the left, this is with the slider on the minimum, where on this type of viewing, you can see that there was a little bit of noise between all the points that were computed. And the more you push it on the right, the more it's going to smooth out to remove these little points that were potentially adding noise. Same effect for the smoothing parameter, where when you have it totally on the left, you basically have the points such as the one you just saw in the previous slide. And the more you put it on the right, the more it's going to try to remove little features which are not adding much which mostly are probably noise from the imagery. Okay, now let's move into the step 3 of the processing. There you have the DSM and automosaic generation, and it's mostly about the outputs which are generated. The automosaic is requires the DSM to be generated, the DSM raster to be generated. So you cannot unselect it and still try to produce the automosaic. However, the DSM is going to be generated in the software by tiles of 5,000 by 5,000 pixels. And at the end, there's an option which is on by default, which is going to take all these tiles of 5,000 by 1,000 and try to merge them together in one single file. So it's easier to access. However, the bigger the projects are, if you have, let's say, 5,000 images, you will end up with a DSM which is maybe 10 gigabyte size. And merging just putting all the information from the different tiles into one single one is a very time-consuming operation. So, and most of the software can handle reading of the different tiles without being them in one single file. So we recommend for very large projects to uncheck the merge tiles, as it's going to increase the processing speed. The grid DSM is basically the same information which is in the raster DSM, but in the format of a point cloud. Finally, the auto mosaic is outputted as GeoTIFF, and we offer two types of techniques to do the auto mosaic. By default, we have the weighted average, which is going to take a little bit of information of each images to generate each color for each pixel. However, in some situation, you may obtain sharper results by using multi-band blending, where each area in the final auto mosaic, you will have areas which will be each only from one single images, and then some smoothing in between the different places. And again, you also have this merge tiles option, which basically has the same effect as for the rest of the DSM. For a very large project, you can save quite some time in processing by not selecting merge tiles. And most of the GIS software will be able to read the tiles even more efficiently than one huge static file. If you select Google Maps tiles and KML, this is going to generate a tree of small files, of small images of 256 by 256 resolution, which is exactly the same format as what is used in WMS, TMS, and services like Google Maps. In addition, we also generate the KML files that allows you to directly import and visualize the auto mosaic in Google Earth. The last outputs are the triangle model in OBJ format and the contour lines. So let's go specifically into, from all these options, if you really wanted to maximize the processing speed, here would be basically in order the most important choices to do. The first one, what takes usually most of the time in a normal processing, is the point cloud densification. So if in your project you're not very interested in the 3D and you're most interested to get a quick auto mosaic, if you have a very, very flat surface, like for instance farming, fields, crops, then you may disable the second step entirely. And you would do that basically by, if this is the software, you can uncheck the second part and then start the processing. This will make that only the initial processing will happening. It will skip the point cloud identification and will directly go to generate the DSM and the auto mosaic. With that, you can save a huge amount of time for areas which are not, where the 3D is not very important. If, however, the 3D is still a bit important, like maybe you have houses and you need the 3D model to correctly generate the auto mosaic, then we would suggest to use to reduce the image size settings to 1/4 the image scale for when generating the point cloud, and to, instead of density optimal, to go for density too low. If you do these two things together, you will have the point cloud will be produced at least 10 times faster than if you put the settings to optimal. And in many cases, the impact in terms of accuracy will not be significant. And this can save you a lot of processing speed. So this is mostly about the point cloud. Then about the auto mosaic and the DSM generation, which is the third step. This is usually the second largest time-consuming part of the software. The first thing to do is to uncheck the outputs which you are not needing. If, for instance, you are not needing the KML and the tiles, processing them will take quite some significant time, so you will save time by not producing them by default. I already said it a few times, but I'll repeat it again. It's also not very useful to, you can save quite some time by not merging the tiles of the DSM and the mosaic. Finally, if you did a flight and by default your GSD is of 4 centimeters, but you're only interested in results in 10 centimeters per pixel, you can also save a lot of time by setting the auto resolution to the real numbers you are looking for example 10 centimeters instead of 4. This will speed a lot the generation of the auto mosaic. Finally, you may also change a little bit the options in the initial calibration, but this is usually not recommended because this is what has the most impact on the accuracy of your project. However, one of the things you can do is disable the rematch option for small projects. If you have enough overlap, you will very likely not have much effect in accuracy, but this will definitely speed up the processing of the first step. If you have very large images or huge projects, then very likely you can also downscale the feature scale to 1/2. It will not have a significant, most of the time it will not have a significant impact on the accuracy, but will definitely speed up by 4, potentially up to by 4 times the processing of the first step. And for large project, then anyway, it's a bit different, but I'm going to talk that just after that. Now more related to if you have a project where you only have a little number of images that manage to calibrate or issues about accuracy. The first thing to note, which is extremely important, is that you can help and improve a little bit by changing option, but the most important is to really have enough data and data taken correctly with sufficient overlap in a flight plan which tries to have as many images nicely spaced in the project where you're doing. So if anything you need to do, fly again and take better data is going to be usually much better than anything you'll try else. However, if you don't have the choice, and you already have your data, here are the tips and the options which will potentially have an effect to improve the accuracy or the number of calibrated images. As already mentioned in the beginning, you could use this alternative processing mode. By using this in the option and processing the datasets, this will very likely improve quite a bit your the number of images that can calibrate, and especially for fields and for vegetation, this can have a huge, very good beneficial impact. Also, if you're using scrolling shutter camera, like the example I showed, it was very wobbly, the alternative processing mode is also able to handle this type of datasets. Some other thing which may happen is sometimes you may have low number of image calibrated because the geotags were way too unreliable. Let's say most of GPS, an RTK GPS will produce 2 centimeter precision. A consumer grade GPS, such as the one you may have on the phone, will be, let's say, 5 meter inaccurate. But some GPS may provide you even with lower accuracy. Mostly it's not the GPS itself, but the synchronization of the GPS in the images, which is very poor. A good example of that is the DJI Phantom Vision drone, which provides very poor GPS information in the images. And if that happens, this may also make your processing very bad, unless you have 2 options. One of the option would be to set the tolerance much higher in the when when you generate in the image properties. And the other one is to simply remove the geotags and process everything without geotags. And you also have a much greater likelihood that everything will work better. For some very, very specific projects, like when you have images of less than 2 megapixels, that could be usually thermal imagery or very deep near-infrared imagery. In that aspect, we would recommend in the first step to select double image size in the feature extraction. And again, I also already mentioned before, you could also decide to optimize externals and leading internals, or just the externals, when you have this rolling shutter camera type. And if despite choosing all these options and trying to do all these different things, if you still have uncalibrated images, then the ray cloud allows you to go in the images and to calibrate them manually by adding tie points. Let's now finish this presentation with a very interesting topic, which is handling very large projects. So what do we mean by very large projects? It's any type of project which are between 1,000 and let's say 10,000 images. The more images you have, the more challenging the whole processing can become, both in terms of resources needed, time to process, and also potentially errors that may propagate. And for very, very large projects, let's say everything which is above 2,000 or 5,000 images, we would really recommend to use either a RTK GPS to have the geotags, or to have quite many GCP distributed in your processing. However, having said that, if your computer has sufficient amount of RAM, like 64 gigabyte or maybe potentially 128 gigabyte of RAM, then the best way is potentially to take these 10,000 images and to process them together, and the software will be able to handle it and to give you some results. However, it's not very often that you have access to such machines with so many such amount of RAM, or you also potentially want to have more control of your data sets to make sure that there's no error starting to propagate at different places. Then what we recommend is to divide your, let's say, 10,000 image project into subsets of 2,000 images. And the way you would divide the whole project in this subset is basically you will make areas which are specially, so if you would make a grid, and each of the cell of the grid should basically have 2,000 images. However, what's very important is that all of your sub-projects need to share a set of common images. As an example, I have here a data set. Okay, this is a very small example just to show, to give some understanding. So in this data set, I have 127 images. The way you would divide this data set is potentially take the first 50 images and to have another data set where you take the other 50 images left, and in addition some of the images of the first data set. So it's not images that just needs to be close to each other. It needs to be exactly images which is the same, and that you process both in both data sets. The reason why this is so important is that these common images will be used when you will merge all the projects together in order to perfectly know how to align these different data sets together. So the way you would do it is you would take your 10,000 images, divide them into subsets of, let's say, 2,200 images. So they have each sufficient images which are shared between the sub data set. And then you will start each data set, you would start the processing of step 1 only. So you can check step 1 and uncheck step 2 and step 3. A very important thing is that you need to make sure also that they each are in the same coordinate system, that you use the same feature scale and full processing mode when processing each them individually. After you have all successfully processed all these different data sets, you will open Pix4Dmapper, and as I showed in one of the very early slides, when you have the wizard asking you to create a project, you will select create a new project using the merge, using merge previous already computed projects. You will then select all of your projects together, and the software will recognize that there's similar images between all the data sets and will be able to align everything in one single project. Then what we recommend, but this is optional, is to go using the Ray Cloud. You would go at the places where you have overlap between sub-data sets, and you would inspect a few tie points on the ground to make sure that everything is well aligned. If not, if you have any issue there and you see that there's potentially a little bit of misalignment, we recommend to add a few tie points in these specific areas, and then click on the Reoptimize button. And this will make sure that all your data sets are perfectly aligned. As an example, this would be a very interesting. This is a very interesting project. So in that example, I believe that we have something like there was around 5,000 images, and in this data set, in this project, you can see these are the 5,000 images together. Oops. What the users did is that it subdivided into smaller cluster, which you can each see them eventually there. But however, this different cluster, we made sure that we shared some images between them, and they each contain a little bit of images of the neighboring project. So we process them all individually using step 1. It can be done on multiple computers, on one single computer, one after the other. That doesn't matter. So you can also save much time into processing by using multiple computers. And then using the merge option, it will then put all the data sets together. However, if your different data sets, for some reason, you cannot mix the subsets such as they share common images, it's also possible to process them. So an example of this one would be potentially if you have a project which has been taken with a UAV, which has GPS, and a project which has been processed from the ground imagery without any ground control points or geotags. So the way to merge them together is that you would identify, you would again split the two projects, and you would process step 1 in each project individually. However, you would also introduce in each project individually tie points, and the tie point you introduce in project 1 should be the same as the one you will introduce in the second project. In addition, they also need to share the same tie point names. So for example, if you have done with a UAV a building, you can do the corner of a building taken from UAV, and you will call them corner 1, 2, 3, and 4. And then from ground imagery, if you've been like going around with a GoPro around your building, you would also create 4 tie points at the corner of the building, and also name them corner 1, 2, and 3, and 4. When you merge them together, the software will recognize that these tie points are the same, the same name, and will perfectly fit the two projects in the same coordinate system, and will merge them nicely together. Another specific case is when your different projects have been taken at very different time and date. Let's give as an example, you are in a very, very large mining site, and you have only a small drone. And you would basically, to cover the whole mining site, you would need to fly one spot, and then another one, and another one. And by the end, to do the whole full covering of your map, some dataset will be taken in the morning, and some will be taken in the evening. The software is very, very good at handling contrast difference. So this is not an issue. Even if you have done datasets morning and evening, normally there is no issue, and the software can handle that very well. However, the sub-projects, it may happen that, especially in mining environments, that you have a lot of shadows. And shadows per se are very good. They are very nice as they provide very good contrast in the images. However, if you have shadows in the morning and shadows in the evening, they move a lot in position. And if you try to merge a project which has a lot of shadows, and the shadows are in one project all in one direction and the other all in the other direction, depending on the amount of shadow you have in your images, it might be very difficult to match from a visual point of view. And in that case, we do not recommend just to share some images, but we do recommend to use the same procedures described above, where you insert manual tie points before merging the projects together. All right. So this concludes the webinar, which was about the options and the workflow of Pix4Dmapper. As a reminder, you can always get a free one-week trial of Pix4Dmapper on Pix4D websites. And the webinars are all available on our support website and also on YouTube, where you can watch them again.